If you've used buses in KiCad, you know that they currently only support a set of nets that all start with the same name, and then have a sequential number at the end. I'm going to call these bus vectors since they represent a sequential list. This bus vector defines A7, A6, and so on, down to A0. What I've been working on is an extension to KiCad that allows you to create buses that contain arbitrary sets of nets. I'm going to call these bus groups. Let's take a look at a few bus groups to see how they work. Here I've defined some USB signals, data plus and data minus. My bus label is using a new syntax for defining groups, which has each signal in a list, separated by spaces, with braces around the ends. You can also give a name to a bus group by adding a string before the first brace. In this bus, I've named it USB 1. This causes the nets that are generated to be named with the bus name at the beginning, as you can see where I have USB1.dp. That way you can have multiple buses that contain similar nets but are still electrically different. Say if you were making a USB hub and you needed 4 ports. Here you see that I've defined a memory bus, and it can contain bus vectors as well as individual nets. Each net will be prefixed with the name memory since that's the name I gave to the bus group. Now, for big buses like this, you might get tired of having these big labels everywhere, so there's another new feature to help called bus aliases. Bus aliases let you define a shortcut name that refers to a set of bus group members. There's a new dialog box that lets you configure them. Here you see I've defined an alias called RAM, and inside it are the same bus vectors and nets that you saw before. You can use the alias inside a bus group label with or without a name. So this first bus will generate nets without any prefix, as you can see where it says OE, and this next one will generate with the prefix. There's also another new feature to help you work faster with buses. You can right-click on any bus and easily pull out any of the bus members. I just choose which member, and then I choose where to place the label, which can be in any orientation. Once I've placed it, I continue wiring. This seems like a simple feature, but it actually points to something new under the hood that I want to talk about. Today the schematic has no knowledge of the connectivity between objects and the nets associated with various wires and buses until the netlist is generated. This netlist generation process can only work over the entire schematic, and for large schematics with many hierarchical sheets, it can be quite slow. The fact that no connectivity information is stored means that actions like highlighting a net can be very slow. On some large schematics, the UI can freeze for many seconds when you try to highlight a net. I have been working on a new connectivity algorithm that fixes these problems. Now I want to caution that this is a work in progress and it's definitely not ready to merge. There are still some edge cases where the connectivity isn't quite right, and some missing features that I need to put in before it can completely replace the old netlisting algorithm. But I wanted to show it off because I think I've made some promising progress so far. Let's take a look at Chris's motherboard project, which is a great test case because it's a very large and complicated design. On the master branch, it will take several seconds to highlight a net. Now you can see, with my new netlist algorithm, it's instantaneous. Another nice side effect is that you can see what net a wire is part of. If you look down in the message panel, you can see the net name and also the object that is driving this net, which in this case is a global label. I hope you've enjoyed this demo. I'll be working to get these features ready to merge in early 2018.